Trigonometry, Part 3, Angles of Elevation and Depression. Today we're going to look at angles of elevation and depression, which is very common word problems for trigonometry. All right, so first we have to identify what it means to be an angle of elevation versus an angle of depression. Now, if we think about, here's kind of a starting point, and we're looking at something over here. Let's say it is a house or, an office building of some sort. Now, you'll notice that when I do the angles of elevation depression problems, I'm going to draw a picture, all right? Now, if I look at this, this makes a 90-degree triangle, which is the whole point of these word problems. Now, in this situation, there's two ways that we can present this, all right? If I go ahead and make this a rectangle, all right, these two triangles are the same, okay? They're identical. All right. Now, the angle of elevation is from the ground to the top of the building. All right. The angle of depression is from the top of the building down. Now, these two angles, when I look at it this way, are going to be the same measurement. Okay. Now, the way that I think about it is that if this is x, then this is x. And if this is, some measurement z, then this is also some measurement z. All right, so if I have an angle of elevation, I have the distance from the building, the height of the building, and angle of elevation. If I have angle of depressions, I have the distance from the building and the height of the building. So I can find the same things. I'm basically finding the same triangle. It's just one is from the ground relative to the top, and one's from the top relative to the ground. So for my first example, I'm going to have to use two whiteboards because the problem is written pretty long. But the angle of elevation from a spot on the ground to the top of a 30-foot flagpole is 20 degrees. How far away is the spot from the flagpole? So here's my spot on the ground. I have a flagpole. There's my flag. Now, I know that this flagpole is 30 feet tall. I'm also told that this angle of elevation is 20 degrees. The question is what I'm looking for. How far away is the spot from the flagpole? So that would be this value. Now, once I have my triangle drawn, now it's just basic trig like we looked at before using trig ratios. All right, 30 is my opposite side, and x is my adjacent side. Which trig function uses opposite and adjacent? Tangent. So we're doing the tangent of 20 equals opposite over adjacent. All right, so I can solve this by, since x is on the bottom in my denominator, I can switch the x and the tangent, which gives me 30 divided by the tangent of 20 equals x. When I do 30 divided by the tangent of 20, I find out that x is 82.42 feet. So I am 82.42 feet away from the flagpole, or the spot is 82.42 feet away from the flagpole if the angle of elevation is 20 degrees and the height of the flagpole is 30 feet. Now, notice that since this says feet, this is feet, make sure you put your units. For the next problem, we're told that my line of sight is 6 feet off the ground. If I'm 100 feet away from a tree and the angle of elevation from my line of sight to the top of the tree is 30 degrees, how tall is the tree? Now, in this case, this phrase, line of sight, is very important. So what that gives me is that the base of my 90-degree triangle isn't on the ground. So I'm not going to use the full height of the tree to find my stuff. I'm going to have to take into consideration this 6 feet. All right. So here's me. Here's my line of sight. All right. So that's the base of the triangle. I have some tree. Now that is a horribly drawn tree. Now what I know is that this measurement is 6 feet. All right, so if this is the base of my triangle, once I know the measurement of this section of the triangle, which I'm gonna use Trig to find out, I'm gonna have to add 6 to get the final answer, to actually find the whole height of the tree. So what I know is that there's my 90-degree angle. When I find this part of the triangle, it only gives me down to here, but doesn't take into consideration the 6 feet off the ground of my line of sight. So the angle of elevation is 30 degrees, so that's 30 degrees, and I know that I'm 100 feet away. All right, so when I do my trig scenario to find this measurement, as I said, I'm gonna have to add 6. So when I set this up, I'm using whichever trig function uses opposite and adjacent, which in this case is tangent again. So the tangent of 30 equals opposite, which I don't know, over adjacent, which is 100. To solve for x, I have 100 times the tangent of 30 equals x. Once I have 100 times the tangent of 30, I find out that x equals 57.74. So x equals 57.74. That means that from here to here is x. So to get the whole height of the tree, I have to do x plus 6. So 57.74 plus 6 equals 63.74 feet. So the whole height of the tree is the x that I just found, which is 57.74, plus 6, which is how high my line of sight is, which is 63.74 feet. So the tree is 63.74 feet tall. If Pinocchio said, "My nose will grow now," would it? All right, so a plane is 1,500 feet above the ground. The angle of depression from the plane to the airport is 10 degrees. How far away is the plane from the airport? All right, so looking at this problem, pause it if you need to, but looking at this problem, I'm gonna make a triangle that fits this scenario. All right, so I have a plane. There's my plane. All right, my plane is 15,000 feet above the ground with an angle of depression of 10 degrees. So here's my airport. My airport is some spot. Now this triangle is not gonna be to scale and it's not gonna be perfect. But if I'm dealing with the angle of depression, this is the triangle I'm using. So I'm told the angle of depression is 10 degrees, and I'm told that it's 15,000 feet above the ground. So 15,000 feet is how high above the ground the plane is, which is this part. So now if I'm looking for how far away the plane is from the airport, I'm looking for this value right there. I'm gonna use whichever trig function uses the 15,000 feet and the x, so this would be opposite over adjacent. So I'm using the tangent of 10 degrees equals opposite, which is 15,000 over x. Opposite over adjacent. So since x is in my denominator, I can switch it with the tangent of 10. So I have 15,000 divided by the tangent of 10 degrees, which equals x. When I do 15,000 divided by the tangent of 10, I find out that x is 85,069.23 feet away. All right, so the plane is 85,069.23 feet away if the angle of depression is 10 degrees and it is 15,000 feet off the ground. For my last example, my line of sight is 8 feet off the ground. If I'm 200 feet away from a building and the building is 50 feet tall, what is the angle of depression from the top of the building to me? All right, so now, when I draw my picture, we have to take into consideration all the things I just read. I'm sorry. If you want to pause it and copy down the problem, there it is. All right, so I'm looking at that same problem. So let's draw the picture. we're saying that the line of sight is 8 feet. So I'm pretending I am really tall. Now, the building, so from the top of the building to the bottom of the building is 50 feet. All right, so now, if the triangle is made from line of sight to the top of the building, all right, then this piece is only going to be 42 feet. All right, now, I'm using angle of depression, so that means my triangle is actually this way. All right, but if this side of the triangle is 42, then this side of the triangle is 42. So the height from line of sight, regardless of what I'm talking about, this triangle or that triangle, is 42. And I know it's 42 because the whole building's 50 and my line of sight is 8. Now I'm also told that I am 200 feet away from the building, which means this is 200 feet. So this is the angle I'm looking for. That is the angle of theta. Now in this case, I'm going to have to use inverse trig, which I have used before, to find out what theta is. So I need to use whichever trig function uses opposite and adjacent. All right, that means I'm using tangent. So the tangent of theta equals opposite, which is 42, over 200. So since I'm trying to find out what theta is, and theta is in tangent, I'm going to use inverse tangent. So the inverse of tangent of that ratio, 42 over 200, and that's going to equal my angle of theta that I'm looking for. And so I find out that this is, by doing the inverse tangent of 42 over 200, 11.86 degrees. Now notice everything we dealt with was in degrees, so make sure your calculator or Desmos is in degrees. If it is in radians, it will not function correctly.